Assalamualaikum everyone. I hope you had a nice weekend. And before we start anything today, I would like to do a small activity just to know how much you remember. And if you don't remember, then I will, refresh your minds. But I need some effort from you as well. And the only thing which I need from you is that in the chat, you will give me anything, any term, any phrase, any particular thing which you remember about the lecture of Thursday. It was about two-lane highways, right? So anything which you remember from Thursday's lecture, the term or the phrase, I don't need any explanation. I will do the explanation. Okay, so you just give me the term. Even if you remember the term, but you don't remember the explanation, just write the term and I will re-explain it for everyone. Go ahead. And I need one response from each one of you. Nobody can give me two terms or two topics. Okay. Anything which you remember from Thursday's lecture. Any term or phrase which you remember from Thursday's lecture, just write in the chat and I will re-explain it for everyone. Shoulder. So there was a combined factor for shoulder and lane width clearance. Shoulder and lane width for the free flow speed calculation. This is the only explanation which I can give about the shoulder. So for freeways and multi-highways, we were taking lane width and shoulder width separately. In two-lane highways, there's one factor for the combined adjustment of lane and shoulder width, and that was affecting the free flow speed. Anyone else? So you can see I'm trying to make an effort, okay? Even for people who did not attend. Please go ahead. You don't need to remember the explanation. As I'm saying, I will do the explanation. Just give me the term which I have used in Thursday's lecture. Any term, any phrase, anything which I've used in Thursday's lecture. Just write it down and I will re-explain it. Even if you have questions, you can write it down regarding that term or something. Flow rate, yeah. So for demand flow rate. Demand flow rate basically refers to the flow rate of the direction in which you are doing the analysis. So you take the volume and then you need three factors to divide the volume: peak hour factor, factor for gradient, and factor for heavy vehicle adjustment. The heavy vehicle adjustment factor, we know the equation from the last topic. Factor for gradient, we have the table. And it depends upon the terrain conditions as well as the flow rate. Number of lanes is fixed, right? For two-lane highway, number of lanes is fixed, which is 1, right? Because we always take one direction at a time, so number of lanes is fixed, 1. Anything else? Like I said, 1. I broke my own rule. So Sam, now you cannot give me any other term, okay? Anybody else who wants to write anything? Raneem, you are done as well. Anyone else? So like I said, one student cannot give me two things. Anyone else? Anyone else wants to ask any or give me any term to explain? No? Okay, Raheem, I will still I will again break my rule because I'm so generous in the class, especially at the time of exam. I'm different. Okay, so PTSF stands for percentage time spent following, and PFFS stands for percentage free flow speed. The difference is percentage free flow speed is calculated as a ratio of average travel speed in the peak hour, peak 15 minutes of the peak hour, and the free flow speed of the highway. So free flow speed is in free flow conditions, and average travel speed is in the peak 15 minutes of the peak hour. So you take the ratio, it will give you PFFS, and PTSF is percentage time spent following. In the peak hour, the amount of time, the proportion of time in which the drivers had a headway of less than 3 seconds between them. So PFFS is a ratio of speeds, and PTSF is basically the ratio of the time when the headway was less than 3 seconds to the total time of 1 hour. So total time of 1 hour is 60 minutes, right? So from those 60 minutes, for how many minutes the headway between the drivers was less than 3 seconds? That is, you take the ratio with 60 and you get PTSF. Okay. So let us move on to the rest of the topic. So after you calculate FG, you calculate the flow rate, and then you move on to the calculation of percentage time spent following. So these are the two equations for calculating percentage time spent following. The first one is the actual equation, but you can see in this equation I need BPTSF, which is base percentage time spent following. Base percentage time spent following. Okay. So base percentage time spent following can be calculated using this equation. Then this equation you can see exponential. EXP is exponential, e to the power. Okay, so this is the power of e. A and B are constants, and I have a table for that. I will show you in a minute. Okay, VD is the flow rate in the direction where you want to find out the PTSF or the level of service. Okay, so VD is the flow rate in that direction where you are trying to find out the level of service. Okay, now if you come to equation of PTSF, so you see FNP here. FNP is the adjustment factor for no passing zones. Okay, so it depends upon what percentage of total length of the segment is no passing zone. In what percentage of the segment passing is not allowed. And I told you on Thursday as well that passing is not allowed on that part of the segment which does not have enough side distance. Okay, so we have a table for that. I will come to it in a minute. Okay, and then VD I already explained, flow rate in the direction of travel, the direction of analysis, and V naught is the flow in the other direction. Okay, so if you want to find out the level of service for direction going from east to west, then V naught will be for the direction which is west to east. Okay, and this also shows the point which I have been saying repetitively, that flow in one direction does affect the other direction as well, and you can see the effect here. Okay, in this equation. So percentage time spent following in one direction is affected by the flow in the other direction. Okay. Another thing which we can calculate for level of service is ATS, average travel speed. Travel speed of the vehicles in the peak 15 minutes of the peak hour, and this is the equation. So we need the free flow speed, we need VD and V naught like I've explained, and then we need again FNP, factor for no passing zone. Now you can see here they are calling this one as FNPA. So this is factor for no passing zone for calculation of average travel speed. This one is FNPP, which is factor for no passing zone for calculation of PTSF. Okay, so this one and this one are different, and for both of them I have different tables. For each one of them I have different table. Okay, so they are not the same thing, but they depend upon again the same parameter, which is the percentage of segment which has no passing zone. Okay, they depend upon the same thing, but the values are not same. Okay, so for example, if you want to find out the FNPA, percentage factor for no passing zone for calculation of average travel speed, then you use this table. In this table we need to find out what percentage of the segment is no passing, 20%, 40%, 60, 80, 100. What is the free flow speed? Okay, And then what is the flow in the opposite direction? V naught. Flow rate in the opposite direction, V naught. Okay, so you need to input all these values to find out the factor for no passing zone for average travel speed, for calculation of average travel speed. This table, this complete table will give you FNPA. And if your values are not matching with the values of the table, you can do interpolation. Okay, so interpolation between the values is allowed, and I will show you. We will do it in an example. Okay, this is the table if you want to calculate FNPP, factor for no passing no passing zone for calculation of PTSF. Okay, so you still need percentage of segment which is no passing zone. Okay, 0, 20, 40. You need directional split of traffic in the peak hour. The demand. Okay, what is a distribution of demand in different directions in the peak hour? So this is distribution of demand, not the capacity, because I told you capacity cannot be 50-50. If you remember in the last lecture, I told you capacity, one direction will have more capacity than the other direction. But this is the actual traffic. What is the condition of actual traffic in the peak hour of the demand? Okay, so you need that, and then you need the total flow. Okay, total flow, VD plus V naught for both directions to calculate FNPP, or to get the value of FNPP. Okay, and then I showed you for calculation of BPTSF, there were two constants in that equation, A and B, and you can see the values of A and B in this table. Okay, so A and B is used for calculation of PTSF. Okay, let us do one example. It is a very long example. I will do half of it because the other half is exactly what we will do today. So you can do the other half, and you can show it to me if you have a problem. Okay, but this will also take a lot of time, so I want you to have the calculators in your hand and prepared, and be prepared and participate. Okay, don't just wait for others to answer. This is for your own good. Okay, so we have class 1 2-lane highway, rolling terrain, peak demand flow rate, peak demand volume is given, 15% trucks, 5% RVs. The highway is a main link to a popular recreation area. This is just some extra information. 60-40 directional split. So out of 560 in one direction, 60% one direction, 40% in the other direction. Peak hour factor is given. The segment is 10 miles, 40% no passing zone. So out of 10 mile, 40% of the segment does not have enough side distance, so passing is not allowed in that. Base free flow speed is given 60, lane width 12 feet, shoulder width 2 feet. There are 10 access points per mile. In this 10-mile section, 10 access points per mile. We need to calculate level of service for both directions. For both directions. So this is what I was saying. I'll do the analysis for one direction, and then you will repeat it step by step in the same manner for the other direction. Okay, like I'm not giving an assignment, but you should do it. This is what I'm saying. Okay, so first of all, let us calculate free flow speed. Now they did not measure the speed in free flow conditions or in some other conditions, so I have to use this equation which I used in the last example on Thursday as well. So the equation is the same. I need base free flow value, which is 60. Then I need the combined adjustment factor for lane and shoulder width. Lane width 12 feet, shoulder width 2 feet. Okay, and I have 10 access points per mile. This is the thing for the other factor. Okay, shoulder width 2 feet means this one, because there's an equal to sign here with 2. This one also has 2, but without equal to sign. So you cannot use this column, you will use this column. Okay, be careful. And again, 12 feet with an equal to sign is here. So 12 feet lane width means this row. So the factor is 2.6. Okay, then access points per mile, 10 access points per mile. Okay, so 2.5. Give me the free flow speed. 54.9. Okay. Okay, now let us see what else do we need to calculate the level of service for class 1 highway. This is a class 1 highway. Okay, so the calculation of level of service depends upon the class of the highway. As you can see here, for class 1 highway, I need ATS and PTSF both. So the calculations will be slightly more complicated, and this is why I have chosen it. Class 2 highway, you only need PTSF. Class 3 highway, you will need PFFS. Now PFFS, as I told you, is a ratio of ATS and free flow speed. So if I give you class 3 highway, then you would have to calculate ATS then to calculate PFFS. Okay, so we need to calculate ATS and PTSF both. Okay, and we have to do it for each direction. So let me go here. I'll just do it for one direction. Direction 1. First of all, I will calculate the volume. Okay, total is 500, 60% in one direction. So this is 0.6. How much volume do I have in one direction? So I'm calling direction 1 the direction which has more volume. Okay, 300 vehicles per hour. Okay, the next thing we need to calculate is the flow rate. Okay, so for calculating flow rate, I have peak hour factor is given in the question 0.88. I need to calculate FHV and I need to find out FG. Let us start with FHV because this is what we have done already. So FHV equals 1 divided by 1 plus percentage of heavy vehicles. There were 15% trucks, 5% RVs. You add them together, 20%. So 0.2. It's given as rolling terrain. Rolling terrain means for rolling terrain, the equivalency factor is 3. Okay. I'm using the same equation which we have used for freeways, and the value is also the same which we have used for freeways for rolling terrain. Okay. So there's nothing new here. Don't believe me, go back to the previous topic and you see the values yourself. FHV is okay, 0.71. Now I need FG. Okay, FG for rolling terrain again, and it will also depend upon what I'm trying to calculate. Okay. So if you are trying to calculate ATS, if you had a level terrain, then no problem. Okay, if you have level terrain, then no problem. The value is 1. But now you have rolling terrain. So you can either use the value from this column or this column. Okay, it depends upon the flow rate and what you are calculating. For class 1 highway, I have to calculate both these things, right? ATS and PTSF. I have to calculate both of them. Okay. So my FG will be different for ATS and PTSF, but I have to calculate both of them. Okay, so let us. So first of all, I need the demand flow rate for my direction. Okay, so demand flow rate will be 300, which is the volume for flow rate. You divide it by the peak hour factor. So how much is this? 341 vehicles per hour. Okay. If I go to the table, 341 is not here, so I have to do some interpolation. Okay, so I'll do interpolation for the calculation of ATS and for the calculation of PTS both. So for ATS, I have to interpolate between 300 and 400, and the values are 0.83 and 0.9. So I have to do some interpolation between them. So the basic equation of our interpolation is 0.83 minus 0.9 divided 300 minus 400 equals Fg minus 0.9 divided by 341 minus 400 plus 0. Sorry. So this is the equation. Now if you organize it, okay, so this is for ATSF. So I will write it as FGA, okay, for the calculation of ATS. So the equation will be 0.83 minus 0.9 divided by 300 minus 400 multiplied by 341 minus 400 plus 0.9. Value of Fg. .86. Okay, good. Want to do it for PTSF? The only difference will be values. So now I have to interpolate between 0.85 and 9. Okay, the other things are the same. So only this value will change, 0.85. So how much is this? It will be 0.8 something. .87. Okay. Okay. So I have calculated the values. Now I will do the calculation for each thing separately. Okay. So let us first of all do the calculation for ATS. Okay. So I'm calculating the flow rate for ATS calculation. Okay, so it will be the volume, which is 300, divided by the three factors, 0.88, 0.71 FHV, and 0.86 FG for ATS calculation. Okay, FG for ATS calculation. You give me this value, and I have to calculate the volume for the other direction as well. So it will be 200 divided by all these things. What is 208? 558 and 372. Yeah, this makes sense. Okay, so after this, then I'll go to the equation for ATS. Okay, this is the equation. I have free flow speed, I have VD, V naught. I need this factor. Okay, for this factor, the table is here. Okay, so I need, no, this one, sorry. So I need the opposite flow rate. Free flow speed 60, no, free flow speed is how much? 54.9, which is 55 almost, right? So this one, okay, and I have the opposite flow rate is 208. Okay, so I have to interpolate between 200 and 400. Okay, and I have 40% no passing zone. 40% no passing zone. So I have to interpolate between 2.4 and 1.9. 2.4, 1.9, 200 and 400. Okay, so
Doctor, you need to fix V2. It's 372.
which one? Ah, okay.
Yeah.
372. Okay, so FNP factors are 2.4 and 1.9. 2.4, 1.9 divided by 200 minus 400 multiply by 372 minus 400 plus 1.9. How much? How much is this? $1.97. Now I can calculate ATS. 54.9 minus 0.0076 558 plus 372 776. Okay, plus no, sorry, minus 1.97. How much is it? $45.7. Okay. Okay. So ATS is done. Now let us move to the calculation of PTSF. Again, the first thing is to calculate the flow rate. I will use the factor for PTSF then. Okay, the FG factor for PTSF. So 0.88, 0.71, 0.87. Five 552,368. Okay. Okay. Now again, if I go, so I need a BPTSF. Okay, for that I must calculate A and B. Okay, so A and B, this table. Okay, so I need the opposite direction flow rate, which is 368. Now this is 2. Okay, so again I need to do some interpolation between 200 and 400 for A and B both. I'm interpolating between 0.0022 and 0.0014. Okay, this is for A, and for B, we have answer for A. Not yet. For B, I will do interpolation between this 973 and 923. Point 0021, okay. And it should be minus, right? Okay, what's the value of B? 0.931 positive, right? Cannot be negative and A cannot be positive. Okay, but your values are correct. I think the values are correct. I think you are doing something wrong with the sign. Okay, so now I can calculate BPTSF. Which is this one, 100. One minus exponential e to the power, okay, minus 0.0021 into VD, which is 552 to the power 0.931. I close the exponential and I close the total bracket. Okay, yeah, tell me BPTSF then. .76. It's in percentage, okay? Base percentage, time spent falling, so percentage. Okay, then I can calculate PTSF, which is this. So base value. So first of all, I need to find out the no passing zone factor, right? And PP. For that, as I said, I have a table. This one. Okay. So we have 60-40 split, 40% no passing zone. So this column and this is split. And the total flow. Did you calculate the total flow yet? No, we need total flow. So give me the value of total flow now. Both directions. Add them together. How much is it? $920, okay. So 920 passenger cars per hour. Okay, so 60-40 split, 40% no passing zone, I have to find out the factor for 920, which is between 800 and 1400. So I will do interpolation between 33.4 and 22.1. Okay, 33.4 and 22.1. Do some interpolation. Okay, so 33.4 minus 22.1 divided by 800 minus 1400 multiplied by 920 minus 1400 plus 22.1. How much is it? $31.14. Okay. Okay. Do I have enough now for calculation of PTSF? Yes, I have. Okay, so BPTSF 52.76 plus FNP 31.14 multiplied by VD, which is for this direction 552, divided by total, which is 920. So how much is it? $71.44. 71.44%. Okay, like I said, percentage time spent falling to percent. The unit is percent. Okay, now I can go and check what is the level of service for this facility. Okay, so my ATS was 45 and my PTSF is 71. Okay, so 45 point something, so I'm in this range. Okay, and 71 is in this range. So this belongs to level of service C, and 71 PTSF belongs to level of service D. In order to have level of service C, I should have both the ranges satisfied. So my PTSF should also have been in this range. So whenever you have such a conflict, you will take the lower level of service D. Okay, I had one value in the range of C, I had one value in the range of D. I will take the lower one, which is level of service D. Okay. This is for direction 1. Okay. Now I leave it up to you to do the same thing for direction 2 as well. Okay. Free flow speed will not change. FHV will not change. The change will start to happen when you are calculating these volumes and factors. Okay, so the volumes will change. Instead of 300, now you will be taking 200 for the other direction. Total is 500, so one direction is 300, the other one will have 200. So the volume will change, and because of the volume, you know the factors depend upon the volume and flow rates, right? So wherever you are using 300, you will use 200, and the factors should be interpolated then for the value which will come for 200. Okay, so FG will change, FNP will change. Okay, like I said, instead of 300, you will add 200 here. Instead of 200, you will add 300 here. And these factors will not remain the same as well, right? Because FG will be then interpolated for the value of 200 upon 0.88. Okay, so all these values will change basically, apart from FHV and FFS, all other values will change. Okay, so again, you have to repeat all the calculations step by step, but by reversing the volumes. Okay, so this is the only thing which is different, but the calculations remain the same. Okay, the same interpolations and everything. Okay, so I will move on. You can do the calculation, you can show it to me, no problem. Okay, whenever they are ready, you want to show it to me, you show it to me, and I can check whether they are correct or not. Just make sure that you do the entire set of calculations. Okay, now if you want to calculate the capacity for any direction of a 2-lane highway, then I have mentioned it earlier that it is fixed under base conditions. The capacity under base conditions is fixed, 1700 for one direction. Okay. Then we can calculate capacity under prevailing conditions using this equation. So this is the equation for calculating capacity under under prevailing conditions. 1700 under base conditions, and this equation will calculate the value for prevailing conditions. Okay. Now in this equation we are using FG and FHV. Now FHV depends upon terrain and percentage of heavy vehicles. Okay, so there is no problem calculating FHV. FG depends upon flow rate. We have just seen it in the previous example that to get the value of FG from the table, we need to know the flow rate and the terrain conditions as well, and what you are calculating. So if you are finding out FG for the calculation of capacity, then whatever your terrain conditions are, for those terrain conditions, just take the maximum value of FG. Because calculated capacity means what? Capacity means maximum flow rate. Okay, so FG for maximum flow rate, because I'm trying to use it for calculation of capacity. So whenever you are taking FG for calculation capacity, you go to the terrain conditions, the FG table, and for the particular terrain conditions you have, you take the maximum value of FG, and that's it. Okay, so FG is fixed basically. Okay, only FHV is changing. Okay, now I have used two terms here which I have used earlier as well. I'm saying this gives the capacity under prevailing conditions, and 1700 is a capacity under base conditions. Now who can tell me the difference between prevailing conditions and base conditions? Tell me, does anyone know the difference between base conditions and prevailing conditions? What's the difference? And you use it.
Actually, in two main things, I guess, for the best condition. For the best condition, one thing is that drivers are similar to the road.
Okay.
And the second thing, let me remember.
Second thing is? What's the second thing? Anyone else wants to elaborate? Anyone wants to add something here? The difference between base conditions and prevailing conditions. And we have discussed it a number of times. So if you cannot answer it now, what will happen in the exam? You may get the same question in the exam, right? Anyone? Okay, so I have noted it down, and maybe I will try to refresh your minds at the time of exam. Anyways, okay.
Doctor, the exam will not be difficult, right?
Yes, it will only have questions which you don't know.
No, doctor.
Very easy, right? Okay, so this is an example which is related to the calculation of capacity. Okay, class 1 rural 2-lane highway, segment of 20 miles, rolling terrain, base free flow speed is given 60 miles per hour, 12 feet lanes, 4 feet shoulders, average 8 access points per mile, 60% segment, no passing zone, current traffic 400 vehicles per hour, total of both directions, 15% trucks, 2% RVs, so total heavy vehicles 17%. 15 plus 2. Okay, direction split 60-40, peak hour factor 0.84. So they have given a lot of extra information here in this question, because what they are asking is just the capacity, and then in what year the facility will reach its capacity if the traffic is growing 8% every year. Okay, so we don't need most of the things which are given in the question. Okay, we just need the
For the second thing, I guess this is for the traffic, if there is traffic or not. Truck, if there's trucks or not. So
yes.
The driver's familiar and there's truck or not.
Yeah. So because of the effort of Hussein to to answer the question, I will tell you the base conditions means ideal conditions, and ideal conditions, there's a list given in both the topics. The list of ideal conditions for freeways and multi-lane highways, and the list of ideal or base conditions for two-lane highways. And it includes the 2 points which Hussein has mentioned: no trucks, all drivers are familiar, and it has, you know, points about lane width, shoulder width, and terrain and all these things. Okay, so these are the base conditions, means ideal conditions when you can achieve maximum flow, and prevailing is actual conditions of the road. So actual conditions will have some trucks, actual conditions will have you know, other things as well. Okay, so I can tell you a joke. It will just take a couple of minutes, a couple of seconds. Once a teacher asked you know, in the class reasons for something. He said, you see this phenomena, and for this phenomena there are two reasons. Who can tell me the two reasons? So one, and if nobody tells, then everybody will get an F today. So one student stood up and he said, "Doctor, I know the two reasons." And then the teacher asked, "What are they?" He said, "One of them I don't remember, and the other one I have forgotten." Okay, so at least Hussein did much better than that. Okay, so first of all, we need to calculate the capacity of this highway. So we know how to calculate the capacity of one direction. Okay, C equals 1700 into FG into FHV. So FHV we can calculate percentage of heavy vehicles, 17%, 15% trucks, 2% RVs, and a rolling terrain equivalency factor is 3. Okay, this is for rolling terrain. Give me the value of FHV here. How much is the FHV here? 0.75. Okay, then I need FG. If I go to the table of FG, I have rolling terrain. Okay, so for rolling terrain, I told you, you just take the maximum value, right? So maximum value for level and rolling terrain is 1. So whenever you are calculating capacity and you have level or rolling terrain, no matter what type of highway you have, FG will be 1. So FG is 1 here. So your capacity will be 1700 into 0.75 into 1. How much is it? One, 275. This is now vehicles per hour. Okay. The other, so this is the capacity. Okay, this is the capacity of one direction. One direction. If you want to calculate the capacity of both directions combined, the total capacity of the highway. So we know in the question that one direction has 60%. So the other direction will have 40%. Okay. So if 1275 is the capacity of one direction, which is 60% of total, then what will be the total capacity? Let me call it CT, and CT will be 1275 divided by 0.6. How much is it? So CT is the total capacity combined for both directions. Okay, and the question they have written that the traffic will be distributed 60-40. So 2125 vehicles per hour. Okay, so we calculate capacity of one direction and then both directions. Now we can the other part of the question is, if traffic is growing 8% every year, traffic is growing 8% every year, then what year the highway will reach its capacity? Okay, there are two ways to do it. One is you identify or you find out in what year one direction will reach its capacity, or you can find out in what year the total flow of the highway will reach its capacity. Okay, so one direction currently has how much flow rate? The total for both directions is 400, and 400 is 60% of total, and this is volume, and capacity is in flow rate. So I will convert it to flow rate. So 0. divided by 0.84. How much is it? So 400 into 0.6 to convert to one direction, divide by 0.84 to convert to flow rate. So how much is it? 86. Okay. So the current flow rate is 286. Now I will use an equation to calculate the number of airs, which I have used in the last topic as well, the growth rate equation. Remember, we use a growth rate equation there as well. Okay, so the future growth rate which I want, for which I want the number of airs is 1275, right? When the facility will reach its capacity, 1275. Current flow rate 286. Multiply by 1 plus the growth rate 0.08, and then you find out number of airs. Okay, so number of airs can be calculated in this manner. So this will be the number of airs in which the facility one direction will reach its capacity, and you can do the same thing for both directions as well. Okay, so instead of finding out number of airs for one direction, you can find out the number of airs for total flow. So future flow will be 2125. Okay, and the current flow will be 400 upon 0.84. Okay, anybody calculate n here? Okay, so if you are doing it for complete flow, then you will use this one as a present value. 19.4 years. Okay. And what about this? What is the current total flow now? 400 upon 0.84. How much is it? 19 years, 19.4, 20 years. It's not a big difference. Okay, so if you write 19.4 or 20 years or 19 years, not a big issue. How much is it? 476. So what is 476? The current total flow. Okay, so again you can do the same thing but using total flow. So total capacity is 2125, 476, the current total flow, and the rest of the thing is same. You can find out n using this method as well. No problem. Both methods are correct and they are acceptable. Okay. So any calculation, any questions or confusion, any questions you want to ask me? Yeah, same. Okay, great. Like I said, two methods to find out the same thing. Okay, these are two methods to find out the same thing. So you should be getting the same answer. Any questions, any confusion, clarification? Everything is all right? Yes.
I have a question regarding the final dates.
What?
Will it be on the same date or it will be changed?
I think they will be on the same day for you guys because it's a 400 level course. They said they are going to make some changes for the common courses like math, physics, and so on. But still, they did not announce it.
This is mean, for example, if it was just for the common subjects, this means that the last week for all students will be the last week in December. The last week of the study will be limited, I guess. I mean.
Yeah, they asked us to do it before the last week, like complete the course before the last week, because some students may be taking some courses from the other course, from the other course.
We don't have, Doctor, any exam at the final week of December, right?
For this course, I don't think so, but it's still wait for the announcement.
Okay.
Just guessing.
Thank you, Doctor.
Okay, that's 2 grades, inshallah, Raneem, by Wednesday, inshallah. Okay, before the break, inshallah. Okay, so I want to ruin your break. Okay. So while you are, celebrating the National Day, I'll use the grades. Okay, everything is done. Okay, see you guys tomorrow, inshallah. Have a nice day. Assalamu alaikum.
Thank you very much, Doctor.
Thank you. Welcome.